Good day. We are on our video number 9 about t-test for independent samples. A t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or a treatment actually has an effect on the population of interest, or whether two groups are different from one another. The t-test assumes your data are independent, are approximately normally distributed, and have similar amount of variance within each group being compared. To put that in action, we have here a dataset and a situation that is being compared, which is GPA of male and female high school students. We have here a group A and group B, a group A that has 50 samples and a group B that has also 50 samples, a total of 100 data samples. But first, since t-test assumes that the dataset should be normally distributed, to test if it is normally distributed or not, we will use Kolmogorov test. Let us first check the group A for the Kolmogorov-Smirnov test of normality. The p-value is 0.16112, which is normally distributed. Let's move on to group B. The p-value is 0.28825, which means that it is normally distributed. So we have assumption that the dataset are normally distributed. So we can now start for the t-test. So as you can see, we have here treatment 1 and treatment 2 for group A and B. Significance level at 0.05 and two-tailed hypothesis. Let us first state our objective, which is there a significant difference between GPA of male and GPA of female high school students? The null hypothesis: there is no significant difference between GPA of male and female high school students. Let us now go back to the t-test calculator for two independent means. Group A for treatment number 1 and Group B for treatment number 2. Significance level at 0.05 and we have two-tailed hypothesis. The t-value is negative 5.04345. The p-value is less than 0.0001. The result is significant at p is less than 0.05. We have here our narrative discussion, the objective, the null hypothesis, the parameters which are significant level at 0.05, confidence level at 95%. The results number 1, mean of group A is equal to 85.38%. Mean of group B is equal to 88.70%. Interpretation number 1, group B has the highest GPA than group A. Results 2, computed p-value is less than 0.0001. Interpretation: since computed p-value is less than 0.0001, therefore, null hypothesis is rejected. Let's move on to our data analysis. The given dataset had been tested with t-tests for independent samples. Since each group were consist of different participants or respondents, each group had been tested with Kolmogorov test for normality with a result of computed p-values such as 0.16112 and 0.28825 for group A and B respectively. This value suggests that dataset in each group were normally distributed since their computed p-value is greater than 0.05. Descriptive statistics result shows that the average GPA for group A or male is 85.38, whereas the group B or female whereas the group B or female got 88.74. This implies that female students get the highest GPAs than male students. On the other hand, testing two datasets with t-tests for independent samples yields to a p-value of less than 0.0001, which is less than a significance level of 0.05. Since the p-value is less than the significance level, the hypothesis will be rejected. Therefore, GPAs of male and female high school students were statistically different.